Okay guys, we're on to the section 2 for chapter 5, electron configurations in the periodic table. Electron configurations are pretty difficult, but the periodic table actually helps us understand where everything's placed relatively easily. So, I've shown this to you before. We have our S, P, D, and F blocks. The S block is over here to the leftmost with 2 electrons in each one of these, except for the 1s, which is separated on both the left and the very far right. And that's because of properties and a couple other things. The D block is here in the center. These are called the transition elements or the transition metals. And then the P block is over here. And then the bottom 2 rows of the periodic table, F, actually kind of belong in here, but if we put them in there, it would just take up too much room, and so we don't actually put them in where they belong, and they would actually go between 6S and 5D for the 4F, and between 7S and 6D for the 5F, and so they go right in here. Groups 1 and 2 are called the alkali metals and the alkaline earth metals. These are the only 2 groups for the S block. They include hydrogen and helium, although hydrogen really doesn't belong to either group, and helium doesn't belong to either group. Helium actually belongs to the noble gases, as we'll get to later. The alkali metals, group 1 of the periodic table, they include lithium, sodium, potassium, rubidium, cesium, and francium. They are very reactive. They have a silver appearance, and they're very soft. You could cut them with a knife, but they are very, very reactive with air, water, and so you never find them in nature as free elements. They're always combined with something else. I will show you in class a nice video that show you how they react with water, and we'll do a little demonstration of that. It's pretty cool. But they are very extremely reactive, and they're usually stored under mineral oil to prevent them from reacting with even moisture just in the air. So group 2 of the periodic table is called the alkaline earth metals, and it contains beryllium, magnesium, calcium, strontium, barium, and radium. They are less reactive than group 1. They are harder than group 1, they are denser, and they are stronger than group 1. They also have higher melting points, and they are less reactive. They're called the alkaline earth metals because they're found after you react the alkali metals on your hearth. If you were to pour water on it, the alkali metals would disappear or react, and what would be left behind would be called the alkaline earth metals. Hydrogen is not considered to belong to any group on the periodic table. It's in a group of its own. It can act as both a group 1 and as a group 7. It's interesting. It could gain an electron or it could lose an electron. So it is put on the periodic table over group 1 because it has the same electron configuration, not because it has the same reactivity or properties. Similarly, helium is put over group 8 on the periodic table, or 18 depending on how you count it, because it has similar properties, not because it has the same electron configuration. So it's kind of interesting. D block elements. The D block elements contain groups 3 through 12 on the periodic table, and they're in that part of the periodic table that's below or kind of splits the left and the right, the very center of the periodic table. In this area we are filling D electrons. We have filled the 4s, and then we go on to the 4D. And if you read in your book, they tell you how you can figure out how many valence electrons there are. Basically, you would subtract 2 from whatever group it's in. There are, and the n value is always 1 less. And these groups have a lot of exceptions to the Aufbau principle. We will discuss a couple in class, and so I do not expect you to remember all of them, but I would like you to read your book and look at the various exceptions on the periodic table. All of these elements are metals. They have the typical properties of metals. They are shiny. They have a high luster. They are easily drawn into wires or into made into sheets. So they're malleable and ductile. So the P block. P block is an interesting block because it contains all the various types of elements. We have metals, we have nonmetals, we have metalloids. The properties vary very greatly because they are metals, nonmetals, and metalloids. What groups do we need to know from the periodic table? Well, if we look at a periodic table, the halogens would be in group 7 or 17, depending on how it's numbered on your periodic table. Halogens need one more electron to be just like a noble gas, and so they're highly reactive and they want to gain that one extra electron. Noble gases are group 8 or 18, depending on how your periodic table is numbered. And they have a complete outer shell of electrons. They're very unreactive and they are most stable. In fact, very simple definition. And the last group that I would want you to know from the P block would be the metalloids. Metalloids you find in things like semiconductors because they have properties of both metals and nonmetals. They have both conducting properties and non-conducting properties, and so that makes them very interesting. Our main group elements are composed of both the S block and the P block, make our main group elements, and so you should know what I'm referring to when I say main group elements, just the S and P blocks together. The F block. F block is located below the periodic table just to save space. We are filling in F electrons or F orbitals at this point. These are called rare earth metals. They're very difficult to isolate in nature because the properties of the elements are so similar. All the actinides are radioactive, and above element 92, which is uranium, are man-made. They're called transuranium elements. Some of those are unnamed at this point because they're still fighting over who discovered it first. We will not discuss a lot of the properties in the F block, but it is good to know what they are. So that concludes this section. We will come back and talk about this final section on the next video. Thanks.